Hello everyone, we're going to do a little review before we get to the more complicated trig solving. Let's make sure we can wrap up everything we've done so far. So let's see, 4.1 we talked about arc length and we talked about sector area, and this says the area of a sector is with center angle 3 radians is 98 centimeters squared. So let me just draw a kind of a sector here and we'll talk about what we know. We know that the angle is 3 radians. It's not 3 pi, it's 3 radians. And we also know that the area is 98 centimeters squared. So there's a formula you need to know. That's 1/2 theta r squared. We know the area is 98. 1/2. We know theta is 3. Remember, theta has to be in radians. You can't do this if theta is in degrees. You have to convert it to radians to use these formulas. So we've got an equation here. We're going to need to move some stuff around. First thing I'm going to do is multiply both sides by 2. 98 times 2. And that gets you 196. So what you have right now is 196 equals 3r squared. We will then divide by 3. And then I'm going to square root that because that'll give me the radius. So the radius is a little bit bigger than 8. We'll say 8.08. R equals 8.08. Now, you got to make sure you answer the question. This says, find the length of the arc. So what I'm actually asked to find is this. So I need to use another formula, S equals R theta, and S equals R, which is that 8.08 number, and I'm not going to round that. I'm just going to use my calculator, and then the radians is still 3. So we're just going to take our answer for our radius, and we're going to multiply it by 3 radians, and we get 24.29. It says to the nearest hundredth. 28.29, and these are centimeters. This is a length. This is the length along the arc. All right. Let's try another one. Wait, did I say? I don't know why I put 28. It's 24. There. I'm like looking at it like 8 times 3 is not 28. 24.29. See? 24.25. I should really just screenshot this number so I stop messing this up. 24.25. Okay. All right, wheels of a car with 16-inch radius are turning at 550. Remember, the speed formula we use is r theta over time, so we know the radius is 16. Theta, if you do 550 RPMs, that's 550 revolutions at 2 pi radians each, that's 1100 pi. 550 times 2 is 1100, 1100 pi. So theta is 1100 pi. You go around 2 pi radians every revolution. So you multiply how many revolutions times 2 pi, and this will be in inches. That's how many radians you get. This is per 1 minute, revolutions per minute. If you figure that out, you will have the speed in inches per minute, but we want this in miles per hour, so I got to do a little dimensional analysis. Let's first cancel out minutes, and I know that there are 60 minutes in 1 hour, so now I have inches per hour. Now I'll cancel out inches. I know that there are, 12 inches in 1 foot, so now I have feet per hour. If I were to type that in, but I need miles per hour. Oops, let's see if I can try that again. Scooch over here. There we go. So last thing we got to do is convert feet to miles. So there are 5,280 feet in 1 mile. Feet cancel. All right. Just got to type it in the calculator now. So 16 times 1100 pi. What else is in the top? Times 60. Okay, now you got to divide, and since this is a quantity, you got to make sure you do 12 times 5280 in the denominator. So 52 point, just give me a, doesn't tell me I'm around, 52.36. 52.36, and we'll say that's miles per hour. Okay. So reasonable speed. We just got to know your formula. Convert into radians. So 75 degrees, I'm going to multiply that by pi over 180. Now the way we do this is we want to leave pi alone if we can. So let's do 75 over 180. Just reduce the fraction without pi. Now I'll go math bracket. So that's 5 over 12. I'm just going to say this is 5 pi over 12. You can't reduce the fraction if you throw pi in there because you get an irrational decimal. So just ignore the pi for a second and reduce the fraction, and your answer is in terms of pi. Same idea going the other way. We're going to multiply by 180 over pi, and this will get us into degrees. So 3 times 180 divided by 8. 3 times 180 divided by 8 is 67.5 degrees. So this equals 67.5 degrees. Just some basic conversion stuff. What else you got? All right, inverse trig. You got to remember when you do these problems that there is a restricted range. Your answer has to come from a certain part. So let's see. If it's inverse sine or it's inverse tangent, I know my answer is going to come from the right side. And if it's inverse secant or cosine, my answer is going to come from the top. So let's see. Inverse sine, they're saying that there is a triangle whose y value is negative radical 3 over 2. I know that's on the unit circle, so I can think of this as a unit circle problem. On the unit circle, there is a y value whose negative radical 3 over 2. Remember, that's 60 degrees. And the trick to this is your answer has to be between negative 90 and positive 90. You can't say 300. This is 300 degrees, but that's not the answer. The answer would be negative 60 degrees, which is negative pi over 3 radians. Tangent of radical 3. Okay, so this is also negative. It's going to come from over here. And this is one you should just remember, that the tangent of 60 degrees is radical 3. So this one is also negative 60. Just have this memorized. The tangent of 60 degrees is radical 3. Anytime you see a tangent of 60, that's radical 3. So going backwards, the inverse tangent of radical 3 will give you 60 degrees. Inverse secant of 2, that means the inverse cosine of 1/2. So let's say cosine's got to come from the top, and I want the x value, the cosine, to be 1/2. That means that this side would be the long leg, so this is going to be 60 degrees right here. So they're all 60 apparently. So then this will be 60 degrees, which is pi over 3. So all three of these have a 60-degree reference angle. Okay. What else you got? Find the exact value. Okay, so here's one where I see 6 over 7. I'm like, that's not on the unit circle. Let's draw a helper triangle. I'm just going to draw a triangle whose sine, so I'll just, like, this is my theta. The sine is 6 over 7. They're saying that the sine of this angle is 6 over 7. And what I need to do is find the missing side. So the Pythagorean theorem, 49 minus 36 is 13. So now I have my triangle, and I'm asked to find the cotangent. So the cotangent of this angle is adjacent over opposite. So this would be radical 13 over 6. So you draw a helper triangle here. You know you're not on the unit circle if the hypotenuse is 7 and you have a side length 6. That's not something we see on the unit circle. Mr. White looks out his window, which is 35 feet tall. So, okay, we got a little building here, and I'm looking out the window, and I look down. So this, you got to be careful here. Angle of depression, that didn't work. Angle of depression is from a horizontal line. So I look out and then I look down at 40 degrees. Now, when you draw this, also realize that that is the angle of elevation of 40 degrees. The car is looking up at me at 40 degrees. And then again, I look down. So this angle is 65 degrees, which means this angle is 65 degrees. And my building is 35 feet tall. I want to know how far the car traveled, which is this distance. So I'm going to just, like, let's call this x and this y. And now I'm going to go ahead and figure out what I can. I can figure out x right away. If I say the tangent of 65, that's 35 over x. So then I can use my calculator. 35 divided by the tangent is 65. Oops, that's not a 5. There we go. 16.32. So x is 16.32 feet. That means at the end, there's 16.32 feet from the building. This is 16.32 feet. But I want to figure out how far the car traveled. So what I'm going to do now is look at this bigger right triangle and write another tangent statement. I'm going to say the tangent of 40 degrees is opposite 35 over adjacent. But the adjacent is x plus y. Now, I know what x is, so I'll eventually get there, but I'm going to multiply both sides by x plus y, and now I get this. Okay, so I'm multiplying both sides by the denominator, and then I'm going to distribute x tangent 40 plus y tangent 40 equals 35. And now, since I know what x is, I can figure out what x tangent 40 is. So if I multiply this by tangent of 40, I got 13.69. So this is like 13.69 plus, just to help you, let's convert this to a decimal. That's 0.839. 0.839y equals 35. So to help you see what you're going to do to solve this, I just made everything a decimal, and now you got to realize you're going to take 35 minus the 13 and then divide. So we're going to take this 35 minus that 13 number, and I'm not using any rounding, and then I will divide by that 0.839 number, and I get 25.39. So y is 25.39. So that means that the car traveled 25.39, and these are feet. This distance is my y value. Okay? What else you got? Last one. Benny's flying his kite with a 200-foot string. Okay, we've done some of these problems. So we got a little kite up here. Let's draw a lovely kite. There we go. And a little tail. It's beautiful. Okay? It says there's a 200-foot string, so that's the diagonal, the hypotenuse here. And it says the wind dies and the kite falls straight down. So, boom, falls straight down. And then Benny, who was here, walks over 150 feet to go pick it up. And I want to know what was the angle of elevation. So to find that, I got to think in terms of theta. This is adjacent, and this is hypotenuse. So I'm going to use inverse cosine of 150 over 200. That'll give me my angle. I'm using inverse because I'm trying to find the angle. The inverse cosine of 150 over 200 is 41.41 degrees. 41.41 degrees. If it tells you, wait, that's a nice little number, 4141, all right. 41.41 degrees. If it tells you what to round to that. If it doesn't, then keep more, and you can always round them off if you need to. So, that's it for the first part of the unit. You can take care of that, and you're in pretty good shape. Next thing we got to do is start to solve some trig equations, so make sure you're feeling good, and make sure you hit that like and subscribe.